So guys, you can see that this is our serial plotter and this is the piezoresistor material. Now I hit it, see, it is showing the vibration. See, I hit it 3 times, it shows 3 curves. I hit it again and again. Now you can see that it is showing the hits I am making. It is showing the vibration. Now hit it hard and it will show a harder value. See, so you can just program this using various methods to make a very nice vibration detector. So this is very cheap and easily available. Let me show you the code. It is very simple. We just initialize a variable called value to read the value from the analog pin, and our sensor is connected to the ADC pin, and then once read we initialize our serial module and we are just printing the values for the serial plotter. That's all, simple as that. Hello guys, welcome to learning microcontrollers. In this video I'm going to show you how we can use an Arduino Uno to plot the detected vibrations using piezoresistor. So let's get started. So guys, this is the piezoresistor module I'm going to use here. This over here, this disk is our piezoresistor and this is our module, and as you can see that it has 3 pins, minus, plus and S. Now the bottommost pin is the ground, the center pin is positive, that is the 5 volt, and the topmost is the signal pin. It can be ADC or digital input, whatever way you want to interface it with Arduino Uno. So the bottom one, the piezoresistor has 2 discs. The inner disc will go to this terminal, the input one, and the outer disc will go to the ground terminal like this. Now guys, this over here is our Arduino Uno. This is the piezoresistor module. Let me again label it for you. The rightmost, if you hold it like this, is the signal pin. The center one is the 5 volt. The leftmost is the ground pin. For the signal pin, if you want to plot the vibration, then you have to connect it to an ADC pin. While you can connect it with a digital input output pin, but in that case you will either get a 1 or a 0. But in our case we want the ADC value. The more force we apply, the higher the value should go. So for that purpose you need to connect it to an ADC pin. So for the ADC pins you have 6 pins, A0 to A5. I'm going to use the pin number A0. You can use any other pin as well, but it must be an ADC pin. Now guys, for the positive you connect it to the VCC, that is the 5 volt pin of Arduino Uno. For the negative, just connect it to the ground like this. In this way our connections are completed. Let me introduce you to the hardware. This over here is our hardware. As you can see, this is the Arduino, this is the piezoresistor module, and this is our signal pin. I connected to the A0, and rest of the wirings are as shown in the presentation. See that. So let's go to our programming. So this is our Arduino IDE, which is a open source free software. Let me zoom in so you guys can see better. You can see that it's version 2.3.2. You can use the higher versions as well. Click on File, New Sketch. Wait for the new window to open. Close any previous window like this. Okay, the new window is opening up. Wait. Okay, it's open. Now guys, first of all, save your work before you do anything else. Press Ctrl S or click on File and Save. Write the name vibration plotting using Arduino and piezoresistor tutorial by LM. Okay, that's great. Click on Save. Okay, let the file be saved. Okay, now the file have been saved as well. Now we click on, we remove these comments. If you want to keep, you can keep them, but I will remove them. Now guys, first of all, we have an ADC pin. We need to read the value coming from the ADC pin. For that we have a command called analog read, and from which pin? A0. If you use any other pin like A1, A2, A3 or up to A5, you just change this 0 to 5, or sorry 5, 4, whatever pin you are using. So I am using A0, so I will write here A0, that's all. Now the value will be read and now we need to store it. Now to store it we will need either an integer or a float. I will use an integer variable. So I write integer, well, that is the value. So value is equals to this, whatever the value is coming from the sensor will be stored in this variable. Now guys, what we need to do is that we need to display the value. So for that we will need a serial terminal. And you can use LCD or whatever you have. I'm gonna use the serial plotter to plot the values. I write here serial.begin. I initialize the serial module, that's the UART port of Arduino Uno. Serial.begin, whatever the baud rate you prefer. I prefer 9600. Now here we just write down serial.println. What we want to print, whatever the value is coming from the sensor. I print them here. Now guys, the problem will be that the value speed coming from the sensor will be too fast. So to slow down the code a bit, now first let's go with the fast, then you will understand what I mean. Okay, let's upload this. Okay, it is done uploading. Now guys, let me show you what I mean. Let's get both the screens together so you can see both the screens. So there is our sensor right next to you, having no force applied on it. See, now I open the serial monitor, go to tools, there is serial plotter, open the serial plotter. Okay, it's opened. See that we are getting values like in between 0 to 2.5, they are like no values at all. Now I apply force on the sensor. See, the values go above to 600, 700. Take a look here. The moment I apply the force, little bit force, it goes to little bit up. But once I apply a lot of force, the maximum it goes is 1000. See, 1024 is the maximum ADC resolution of this 10-bit ADC. See that right now it has fallen like to 14, 13, 12. But as soon as I press it, goes up. Now that's what I was talking about. The speed is too fast. To slow down the speed, we just need to add delay here. Now you can change this delay to adjust the speed. I will give you the code in the description of the video. So I change the delay to like I add 200 millisecond delay. So it will slow down the code a bit. Okay, the new code is being updated. Okay, it's done uploading. Again, go to the serial plotter. See that now the values are like 4, 5, 6. Now I hit it with a finger. See the values go up. Okay, let me zoom out a bit. See, the values went up the one hit only. See, that was just a one hit, rest are again back to 0. Now again I hit it. See the value go up for that hit. Now I hit it twice. See, another hit. I hit it thrice. See, another hit. Now I hit it very hard. See, a very hard hit. Now I will hit it with a marker. Okay, see, this value is even harder. See, the harder you hit it, the more vibration it shows. So it depends upon how you are hitting it. Now the point is, if I hit it again and again, then I can detect the vibration. Now I decrease the delay to show you what I mean. I make it just 50 to make it faster, so you will see that how the vibration is detected. Okay, it is uploading, done uploading. Okay, the new code is uploaded. Now see, it is going faster. Now we are just in between 0 to 3.5. This is like no value. See here. Now I hit it. See, the value went up to 450. I am hitting it again and again. See, it is showing all the hits. See, it went up to 700, 600, 500. Now when I lightly hit it, see, I am lightly hitting them. See, it is showing us the vibration. So in this way, this is a very cheap module, very difficult to use, but you can work on the programming. You can do some efficient programming to make a vibration detector using this. It can do your job as well. So it is a great module. So guys, this is it. I hope you guys learned something from this video. I will share the code in the description. So thank you very much for your time, guys. We'll see you in the next video.